This section examines camshafts and drives. The position of the camshaft depends on the design of the engine. It can be in the engine block, close to the crankshaft. This is called a pushrod or overhead valve system. Or there can be one or two camshafts mounted in the cylinder head. But in both designs, it does much the same job, driving the valves and the distributor, and sometimes the fuel pump and the oil pump. The camshaft is made of hardenable iron alloy or steel, and it can be cast or machined. The cam lobes are ground to the proper shape and position in relation to one another. Accuracy is crucial. If the cam is not exactly the required shape, or if it becomes worn, there can be impacts, fast valve wear, or noisy operation. The bearing surfaces on the camshaft are ground smooth, and the distributor drive gear is machined into the shaft. The cam lobes are then flame or induction hardened. The camshaft has a cam for each valve. In some cases there is an additional cam known as an eccentric to operate the fuel pump. A gear on the camshaft drives the ignition distributor and often an oil pump. The cam lobe performs three jobs. It opens a valve at the proper time and gives it proper lift. It lets it stay open for a sufficient time. Then it lets it close at the proper time. Accurate valve timing is crucial. Valve timing can vary from engine to engine, as set out in manufacturer's specifications in the valve timing diagram. The shape of the cam is called the cam profile or contour. With the valve lifter resting on the base circle, shown as A, the valve is fully closed, and there is clearance between the rocker arm and the valve stem. The cam rotates. The nose of the cam, B, reaches the valve lifter, and the valve is fully open. The closing flank, C, closes the valve gradually so that it doesn't pound against its seat. On engines without valve lash adjusters, a quietening ramp is built into the shape of the cam. This makes for quieter operation during the opening of the valve. The shape of the nose determines how long it stays open. The camshaft must always be synchronized to run in time with the crankshaft. This can be done by gears, chains, or toothed timing belts. Gear drives are most common in engines with the camshaft in the cylinder block, and in heavy-duty diesels. Timing belts and chains are used on overhead camshaft engines because the camshaft is further from the crankshaft. This is a typical chain drive system. It uses a hydraulic tensioner which is fed by oil under pressure from the lubrication system. The chain also uses guides to reduce noise and vibration. The toothed timing belt is made of fiberglass or wire-reinforced synthetic rubber. Its teeth match those on the crankshaft and camshaft pulleys. Timing belts are quieter than chains, but usually require regular manual tensioning. They also have a shorter life than chains. They need regular replacing around 80,000 to 100,000 kilometres. If a belt breaks, it's not only inconvenient, but on some engines it can cause a lot of damage.